In this second objective, we're going to take a look at the production function and hiring workers in this case, and then what happens to our output. Goes back to a couple principles, and the first one is the cost and benefit. As we add additional workers, how do they benefit us? We're also going to look at the law of diminishing returns. The law of diminishing returns is as you add input, the output, marginal output, will tend to decrease. And so we're going to take a look at that and ask some questions about it. So let's go ahead and get after it. Thank you. Let me share my screen with you. I always say the fourth take is a charm. Okay. So again, the cost of production. All right. What is the production function? The production function basically says, as we change inputs, what happens to output? So it's a relationship. And we can look at it in a table, an equation, or a graph. And we're going to go ahead and present the production function using an example. So in our example, we have Farmer Jack, and he's going to grow wheat. He's got 5 acres of land, and he can hire as many workers as he wants to hire. Later on, we're going to classify these costs according to their categories, land being a fixed cost, and we'll define that later on, and workers being a variable cost, again, which we will define in the next objective. So let's go ahead and look at this in a table form, and then we'll look at it graphically as well. So at this point, we're going to say that Farmer Jack does none of the farming himself. He's a coordinator. Or let's say he's retired and he is hiring people to solely produce this wheat. If he has no workers, he doesn't get any output of wheat. Now he decides to hire 1 worker. His output of wheat increases by 1,000. Okay, so we're just saying, okay, we went from no workers to 1 worker. That's a gain of 1. And how much wheat do we now have? 1,000. So you can look at this as the cost being the worker. There's our cost. An increase in cost of 1, our benefit, an increase in 1,000 bushels of wheat. Now, what happens when I add a second worker? I want you to think about that for a moment. Let's say worker 2 is exactly like worker 1. They are carbon copies of each other, have the same motivational levels, the same everything. How many bushels of wheat do you think that the second worker will add? And I can tell you, because I know the law of diminishing returns, that worker 2 is going to add something less than 1,000 bushels of wheat. How do I know that? Well, think about this. If there's only 1 worker, they can decide when to do something, when not to do it. They have all the capital available to them at their disposal when they need it. Yet when Farmer Jack hires the second worker, there's a thing which has to take place, and this thing is called a coordination of effort. If you've ever sat in a meeting, you know that you're coordinating effort. And while you're coordinating that effort, although important to the work itself, work is not actually being done. Meaning here, we are not putting out additional wheat. So I can tell you that when we hire this second worker, because of coordination of effort, then what's going to happen is we're going to have something. Let me go ahead and. We're going to have something less than 1,000. So let's go ahead and look. Notice when we hired the second worker, it is, in fact, a gain of less than 1,000. We hired the first worker, we got a gain of 1,000. We hired the second worker, we now get a gain of 800. Notice as we continue to hire workers, the gain that we get from each worker is less and less. So if we were to look at this and say the gain of the next worker is 600, the gain of the next worker is 400. Notice I'm looking at this per worker or incrementally as we've defined it in our course, and 200. If we look at this graph right here, as you can see with the graph, that for each worker, this idea of the quantity of output is increasing, but it's increasing at a decreasing rate. So if I were to take the slope and calculate it here, it would be very positive. Here, a little less so. Here, a little less so. Again, remember chapter 3 when we talked about this idea, a little less so, barely positive. And what do you think might happen here at worker 6? Worker 6 might be here or here, but it's actually going to start to decrease. So what happens is I ask myself, should I hire worker 6? And the answer is no, because worker 6 is not going to produce any more output, probably be 0 here at worker 6. So what I do is I take a look at, okay, if I hired worker 6, they're not giving me any benefit. So as I look at that cost benefit decision, worker 6 does not increase my output. So I would hire, the right amount of workers to hire right here is 5 workers. I will have an output of 3,000 bushels. That 5th worker will still be beneficial. Again, we're ignoring the cost of the labor at this point. But I can tell you that the law of diminishing returns means that as you add this input, your output will increase, but it will increase at a decreasing rate. Okay, what we've actually just done is we've calculated the marginal product of labor by looking at it incrementally. And again, we're just looking at how adding workers while holding labor, while holding land constant, how do those workers increase our output? Okay, now we're going to start with some notations because we're going to look at this a little more mathematically, but you can kind of see we're just looking at things incremental. So what we're going to do to measure the marginal product of labor is we're going to say the marginal product of labor, or MPL, marginal product of labor, is equal to the change in quantity divided by the change in labor. So this becomes another formula for us to know and to have. And again, it helps us make some of those decisions that we talked about in Objective 1. Okay, so here's an example. This is just the graph that we had a moment ago, and we're going to do the same thing, knowing that the marginal product of labor is equal to the change in the quantity divided by the change in labor. In this particular scenario, we're going to say our change in labor is 1. So 1 minus 0 is 1. 2 minus 1 is 1. 3 minus 2 is 1. So we're looking at these as a factor of 1. Then we want to calculate our change in quantity. So change in quantity just says we went from 1,000 minus 0, that is a benefit of 1,000. We went from 1,000 to 1,800, change 800. 2,400 minus 1,800, change is 600. 400 and 200. Okay, now you're probably seeing the pattern that the marginal product of labor, as the labor goes up by 1 unit, the marginal product of labor decreases by 200. This is textbook land. It doesn't always work this nicely. So what we can do is simply divide 1,000 by 1. Our marginal product of labor is 1,000. 800 by 1, 800. 600. 400, and 200. Okay, let me erase my ink on the slide so you can clearly see how this works out. Sometimes this doesn't want to grasp my, there we are. Okay, there we go. So there's our marginal product of labor. Now, we can look at the marginal product of labor is the slope of the production function. So our production function, the slope of it is the marginal product of labor. Remember some time ago when we started introducing marginal, we said that marginal is a slope of whatever we're looking at. So here, the slope of the product of labor. So the marginal is the slope of the product of labor. And here is the product of labor. And the marginal product of labor is just the slope of the production function. So this graph beside of us here on the right-hand side is just the production function, which illustrates as we add workers, as we go from 1 to 2, 2 to 3, we can say, okay, the number of workers, 1, and our output is 1,000, so we graph that. Then to determine our marginal product of labor, we're going to take that change in the quantity divided by the change in the labor, or the slope of the production function, and that's going to give us our marginal product of labor. Here's another example just to make sure you understand it. If you do, go ahead and fast forward. Here we have a small production firm that makes sweaters. Here again, these are a number of workers. Here's our total output. So as we look at this, we can say we added 1 worker, right? That's our change in labor. So I'll put change in labor. We added another worker. Okay, incrementally going up by 1. That's not always the case, but we're going to work that here. Okay, when we added what is our change in output, change in quantity. Here we went from no workers, no output, to our first worker, gives us 4 output. So our output here will be 4. 10 minus 4 is 6. 13 minus 10 is 3. 15 minus 13 is 2. And 1. So our marginal product of labor, again, which is the slope of the production function, is 4, 6, 3, 2, 1. So here's my question to you is how many workers to hire? Now, most of you would say, okay, I'll take the 5th worker because I am still getting some output. And again, we are kind of ignoring some questions that we would really need to answer this well, and that is, what's the cost of labor? What are we paying our workers per hour? Because if the cost of labor here is, say, $10, okay, and we can only sell a sweater for the price of sweaters is 6, I would say, well, we're definitely not going to employ 5 workers, and so on. So we'll look at that coming up. Okay. Here is our sweater example. So here's our output of sweaters graphically. And here's our quantity of labor. Notice it obeys the law of diminishing returns, that this production function increases at a decreasing rate. Remember that the marginal product labor is just the slope of this production function. Okay. Now, if we took this production function, and we were able to lift it off the screen and flip it over, we would end up with a total cost curve. Because right now we're only saying our only cost to this is labor. So notice that this production function, here it is convex, here it is concave, and notice that as we look at our total cost, and again, that would be our cost of labor, and our output over here, they're kind of mirror images of each other. Remember, our total cost curve is related to our supply curve. So that's why we look at this. And again, just keep in mind that the marginal product of labor is equal to the change in the quantity divided by the change in labor, or is simply the slope of this production function. Somebody is knocking at my door. I guess they're going to have to wait. So why is marginal product of labor important? Well, it's because we really want to make some good decisions here. Okay? So are we going to benefit from hiring an additional worker? Again, what is the right amount of worker to hire? So why did I know that the output rises by a smaller amount for each additional worker? And this is because that we're holding all other inputs constant. Here, land, we're holding constant. And let's imagine maybe Jack only has one tractor. And if you only have one tractor, you really have to do a lot of coordination of effort. I'm not saying meetings aren't important, but I'm saying that if I'm in a meeting, I can't be teaching at the same time. So that decreases my overall productivity. So the marginal product of labor diminishes as labor rises. And this is true of fixed inputs, things like land, because aren't we eventually going to hit capacity of our land? Aren't we going to hit our capacity of capital? So when I look at this, and I laugh because this is so true in my business, is I like to use one specific pitchfork. Okay, it looks kind of like that when I clean stalls. And if my husband's using it, I am less productive. And so one would think I could just go out and buy another pitchfork, but that's a cost, right? But I have yet to find the exact one that I like. So again, the diminishing marginal product is based upon the law of diminishing returns. Okay, so hopefully with those examples, we're done with this objective. So I will meet you back for objective 3. Thank you. Have a great day. Stay well.